Now that we know the property of anonymity, let us try to find out the equivalence of these three properties: strategy, proofness, ontoness, anonymity, with median voting rule in the single peak domain. And this equivalence is given by this result of Muller from the same paper. It says that a strategy proof social choice function f is onto and anonymous if and only if it is a median voter social choice function. So it essentially characterizes the space of social choice functions which are strategy proof onto and anonymous. And quite interestingly, it turns out to be the median voter social choice function that we have discussed so far. So the reverse direction is fairly simple. So we'll have to show that the median voter social choice function satisfies these three properties. We have already seen that it is strategy proof from the previous theorem. It is anonymous because if we permute the agents with their peaks unchanged, the outcome does not change. The median voter only looks at the peaks and finds out the median of that along with the phantom peaks, and that is completely anonymous. It is also onto. If you want to pick any arbitrary alternative A, then you may put all the picks of all the players at that position, at that A. The outcome will be A irrespective of the positions of the phantom picks, because median is always going to be that alternative A. So therefore it is of course onto. So that was the easier direction. The harder direction, that is the forward direction, where we have the social choice function satisfying these three properties, we'll have to show that that must necessarily be a median voting rule. So this is the forward direction. Let's without loss of generality assume that the leftmost and the rightmost points are 0 and 1 respectively. And with this notation, pi superscript of 0 means that player I has a preference which has a peak at the leftmost point. So leftmost with respect to this the common ordering over this preferences. So pi0 would look something like this. So the topmost one is on the left, and it monotonically decreases because we are only considering strict preferences. Similarly, pi1 is the agent's preference, where the peak is at the rightmost. This is here, and it decreases in this way. Now the proof is a little longish, and we are going to prove it via smaller claims, and it is also constructive. So we will construct a median voting rule which needs the phantom peaks to be chosen such that this outcome of an arbitrary social choice function f matches the outcome of that median social choice function which we construct, right? So let us go over this. So the first thing that we need to construct is the construction of the phantom peaks. So remember the social choice, if we call f of median social choice function, it is the median of the phantom peaks b, which are n-1 in number, and then you have the peaks of the players, right? So this can vary, but once we fix a specific social choice function, we actually fix the phantom peaks, and that is what we are going to construct here. The phantom peaks as follows. We are going to construct the jth phantom peak, and j varies from 1 to n-1. So here is the construction. We look at the first n-j peaks to be the on the leftmost point. So this p subscript of I superscript 0 means that all these players have the peak on the leftmost point, and for the other players all the other j peaks are at the rightmost position. So consider this profile, this preference profile, apply f on that. That is going to be our yj, that is the jth phantom peak. So for player, so if you have only one, then you have n-1 peaks on the leftmost side, and the last peak is on the rightmost side, and slowly you are migrating towards the other extreme, where you have only one peak on the leftmost side, all the n-2 peaks on the rightmost side. And now which agents have which peaks does not really matter, because we are going to assume anonymity anyway. So as long as the peaks remain the same, the phantom peaks will also remain the same. Now here comes the first claim. we say that in this order, whenever we are having this yj's, if we can order them as y1 is less than equal to y2 less than equal to so on yn minus 1. So this is what this means. So how can we prove that this holds? So we have already defined yj. So what is yj plus 1? Essentially we have moved this j minus 1. This j minus 1 agent has now the peak at the rightmost position, right? So where in the earlier yj this had the peak at the leftmost position. That is the only change that has happened in yj plus 1. For all other players, the peaks are as before. Now what should happen for strategy proofness? So if you look at this preference profile, because f is strategy proof, in this preference the outcome of yj should be preferred more than yj plus 1. Because if that is not true, then player n minus j would have manipulated in that preference profile. But we also see that p n minus j0 is single picked. So what does this mean? Yj is yj is preferred more than yj plus 1. And this preference profile p n minus j has peaked on the leftmost side, so it can only monotonically decrease. And whenever we say that yj is preferred more than yj plus 1, that means that yj plus 1 is going to be living on the right hand side of yj. So this is automatically satisfied, and you can change j to any other value because j was arbitrary. You have this inequality satisfied for all j. So that was really very simple implication. Now we are going to look at the next step of this proof, where we consider an arbitrary preference profile where the players have these preferences, player 1 to n, and we will use this lowercase of pi to denote the peak of player I. Okay? So this lowercase pi's are just the peaks of this single peak preferences. Now here comes our next claim. Now suppose the social choice function satisfies these three properties. Then what we are going to claim is that, and this is going to be the median of those agent peaks augmented with the phantom peaks, and that is what we actually wanted to prove. So this is the once we prove this, we are done, because that is the final thing that we wanted to prove. We have constructed a set of phantom peaks. Now you give me any preference profile. If we take the median with respect to those preference profiles and the phantom peaks, we are always going to get the outcome of this social choice function f. So therefore, any arbitrary social choice function which satisfies these three properties must be a median voting rule, median social choice function. Okay, so let's prove this result in two stages. So first we observe that we can assume without loss of generality this ordering over the agent peaks, and this is possible due to anonymity. So if we have any arbitrary peak, we can always relabel these agents such that this p1 is less than or equal to p2 and so on, less than or equal to pn. This inequality holds, and that should not change the outcome because the social choice function is anonymous. Now let us assume that this A is the median of all these agent peaks and the phantom peaks that we have constructed. Our job will be to show that this is exactly equal, this A is exactly equal to FP. Now naturally there can be two cases. So when we are taking a median of a bunch of numbers, it can be, the median can come from the agent peaks or it can come from the phantom peaks, and we are going to consider these two things separately. So let's assume that A is a phantom peak. So it is coming from this bunch of numbers. So let's say without loss of generality, A is yj for some j which is living between 1 to n minus 1. Now we should notice that there are n minus 1 points. So there are n minus 1. So let's say there are n minus 1 phantom peaks and there are n agent peaks. So there are 2n minus 1 points altogether. And this yj is the median of that. That means n minus 1 of them of these numbers live on the left of this, and the other n minus 1 live on the right. Now, because of the previous claim that yj's are always ordered, yj's are less than equal to yj plus 1, so what should happen is that because yj is the median, all the previous j minus 1 should be living on the left hand side, right? So if yj is living here, there should be j minus 1 phantom peaks on the left of it, and there should be n minus j agent peaks, because together this phantom and agent peaks, it should be equal to n minus 1. And similarly here also there should exist n minus 1 points, and therefore because there are j minus 1 on the left and this is also a phantom peak, there are n minus 1 minus j number of phantom peaks on the right hand side, and there are j agent peaks. So this should be the picture how it looks like. Now we know that there are this n minus j, and we have also assumed that this ordering holds for the agent peaks as well. So these peaks are on the left hand side of yj, and the rest of the peaks are on the right hand side. Now we are going to use a very similar transformation from this the very special preference for which we get this yj to the actual preference p, which is p1 comma p2 to pn, and we are going to do this transformation for one player at a time. This is something that we have already used in several proofs. So let's say, so we know that this is true. This particular thing is, by definition, we have defined yj in that way. So n minus j of this peaks on the leftmost side, and the rest of the peaks on the rightmost side. Apply f on that. That is going to be your yj. Now what we are going to do is we are going to just change player 1's preference here, and from p0 it is going to p1, and for all the other players the preferences are the same. And suppose that outcome is b, and we are going to show that b should be equal to yj. Now how should we prove this? We know that because the social choice outcome is yj here, it must be the case yj should be strictly preferred over b in this original profile, because if that is not true, player 1 would manipulate in that profile. And because p10 is the leftmost one, so p10 has the peak at the leftmost side, and it falls in this way. Therefore, if anything, so yj is more preferred, so there is something yj which is more preferred than b, then it must be the case that b lives on the right of yj. So that is by the definition of this preference ordering and the single peak preference. Then again, when we migrate to this new preference profile, we can say that this alternative b is more preferred than yj, because if that is not true, then player 1 would have manipulated again in this preference. So whatever is the current outcome should be preferred more than any other outcome where player 1 is deviating to something else. Now we also know, because of the fact that we have just proved, so by construction this p1 is left of yj, so p1 is left of yj, and the fact that this is single peak. So what is happening here is for p1, so let's draw this figure here. So p1 is the peak of player 1 in this case, in this preference p, and yj we have just seen that this is on the right hand side. Now where can b live then? We know that b is more preferred than yj, so b cannot live on this side, because if that was the case, and given that the peak is on the other side of yj, then b must be less preferred than yj. Because b is more preferred than yj, the only possibility of b is on this left hand side of yj. It can live on the other side of the peak as well, but it must be on the left hand side, it cannot be on the right hand side. So this implication is true for the single peak preference. Now we can see that by strategy proofness we got yj is less than or equal to b, and also b is less than or equal to yj. So which means that b must be exactly equal to yj. Now you can see where we are heading. So from this preference profile you can now change this p2 to p2 superscript 0 to p2, the actual profile, actual preference of player 2, this profile p, and you can apply a very similar argument to conclude that in that outcome, that social choice outcome should also be yj, right? So we can repeat this argument for the first n minus j agents to get that this is also going to be yj. Now we are going to consider the other preference. So till now we have exhausted all the peaks which were on the leftmost side. Now we'll have to consider the rightmost peaks. Now here we are doing it from the right hand side. So for player n, let us assume that the preference changes from pn1, which is the peak on the rightmost side, to the pn, which is the actual preference for player n. And let's say again this could be potentially different. Let's say it's b, and we can use a very similar argument because yj has to be, so it has to be strictly more preferred than b in this preference for player n. That means that it has to be b has to be less than or equal to yj, and that is because of the fact that the peak is on the rightmost side. So the peak is at the rightmost side. So if yj is more preferred than b, then it must better be on the right hand side of b. And similarly we can apply the same argument that b is more preferred in this preference pn than yj, and we also know that yj is less than or equal to pn. That is the thing that we have proved at the very beginning. This should immediately imply that yj must be on the left hand side of b, and this two together gives that b must also be equal to yj. Now repeat this argument until you come back to this fact that f of p is actually equal to yj. So what we have proved, let us go back to the original claim, that if a is a phantom peak, we just showed that this a must be equal to that phantom the phantom peak, then it must be equal to the social choice outcome f of p.